The response of the climate system to an initial forcing is modified by feedbacks. Increased by self-reinforcing, or positive, feedbacks and reduced by balancing, or negative feedbacks. The main reinforcing feedbacks are the water vapor feedback, the ice albedo feedback, and the net effect of clouds. The primary balancing mechanism is radiative cooling. As Earth's surface gives off more heat to space in response to rising temperature. In addition to temperature feedbacks, there are feedbacks in the carbon cycle, such as the fertilizing effect of CO2 on plant growth. Uncertainty over feedbacks is the major reason why different climate models project different magnitudes of warming for a given amount of emissions. As air warms, it can hold more moisture. Water vapor, as a potent greenhouse gas, holds heat in the atmosphere. If cloud cover increases, more sunlight will be reflected back into space, cooling the planet. If clouds become higher and thinner, they act as an insulator, reflecting heat from below back downwards and warming the planet. The effect of clouds is the largest source of feedback uncertainty. Another major feedback is the reduction of snow cover and sea ice in the Arctic, which reduces the reflectivity of the Earth's surface. More of the sun's energy is now absorbed in these regions, contributing to amplification of Arctic temperature changes. Arctic amplification is also melting permafrost, which releases methane and CO2 into the atmosphere. Climate change can also cause methane releases from wetlands, marine systems, and freshwater systems overall. Climate feedbacks are expected to become increasingly positive. Around half of human-caused CO2 emissions have been absorbed by land plants and by the oceans. On land, elevated CO2 and an extended growing season have stimulated plant growth. Climate change increases droughts and heat waves that inhibit plant growth, which makes it uncertain whether this carbon sink will continue to grow. Soils contain large quantities of carbon and may release some when they heat up. As more CO2 and heat are absorbed by the ocean, it acidifies. Its circulation changes and phytoplankton takes up less carbon, decreasing the rate at which the ocean absorbs atmospheric carbon. Overall, at higher CO2 concentrations, the Earth will absorb a reduced fraction of our emissions.